So if I was drawing a picture of my cardboard, it's 30 centimeters by 25 centimeters. Squares are cut out of the corners, so maybe I draw little squares out of each of the corners. And this is very similar to the paper box problem we did to begin with. And I'm going to label the length of those squares, the side lengths will all be x. So those squares will be cut out, then everything will be folded up. Does it make sense now that this side will be 30 minus 2x? Because you've cut an x off here and cut an x off there. And similarly, this length will be 25 minus 2x. And so when you fold things up, and if you like drawing, you can also draw a little three-dimensional box of it folded up. That would mean that we have 30 minus 2x for this side, 25 minus 2x for this side, and a height of x. And if we're trying to figure out our volume, it's length times width times height, and we set up our volume. And it's in factored form, and we can use our skills at graphing to get an idea of what this is going to look like. So we've done A. We've written a polynomial function to represent volume in terms of x. Graph the function. Figure out its domain. So when I'm graphing the function, I'm going to use my n behavior, my x-intercepts and y-intercepts, and multiplicity to graph this. So if I want to figure out my x-intercepts, set this equal to 0. It's already factored. So x is equal to 15, x is equal to 12.5, and x is equal to 0. And so going to graph this, we have an x-intercept at 0, one at 12.5, and one at 15. What does the n behavior look like? What kind of graph would this be? Well, if we look at our x's, we would have a minus 2x times a minus 2x times an x, which would make a positive 4x cubed. It's an odd function, so it's going to act like a line with a positive slope. So then we know for graphing, we're going to start down here. The multiplicity of each of these is 1, so each time it's going to just go straight through and end up towards the right. This is our graph. What is our domain? Now, the domain of that graph is everything, XER. But the domain in this question can't be everything because we're dealing with a real-life problem. You can't have a box with a negative height. That doesn't make sense. You also have to realize that what would happen if I cut out a square of size 15? Well, I would have no paper left to cut out. Can you see that the biggest square that you could cut out, well, it would still result in nothing, would be 12.5? If you cut out 12.5 this way and 12.5 this way, your 25 is all used up and you just have a thin piece of paper with no volume. And so the only part that makes sense is this section between 0 and 12.5. So if we wanted to write our domain, And on the exam, they would probably technically also accept the equal sign, because if you decided not to cut anything out, you do still have something with zero volume. Not very useful, but I guess it still does exist. Whereas if you cut out more than 12.5, it's not even possible to do. And our setup allows us to go to the next part where we want to find the maximum volume and the size of square. So we're going to put this into our calculator, get a graph, so we need to have some sort of scale for our y, draw this part so we can see the yellow part, and then find the maximum. So we go to our calculator. We're going to have 30 minus 2x, 25 minus 2x times x. And if I hit graph right now, I have my old window from before, which apparently goes way too high. So again, it might be helpful to go second table and see between 0 and 12.5, how big do the numbers get? Well, it looks like at 5, it's at 1500. And that's the biggest it gets. So I'm going to go to my window. I'm going to change things here. I don't need to go up to 50. Maybe I'll just go up to 15. And it goes up to 1500. I don't know for sure if that's the max, so I'll go up to 2000. And I'll see if the graph does a nice curve like what we sketched by hand. And now that we have that graph, we can find the maximum. Second, calculate. Number 4, the maximum. Now again, you can use your left and right keys to get to the left side. A shortcut, since I know this is from 0 to 15, can you tell that 3 is definitely to the left of the maximum? So if you just push 3, it'll automatically go to 3, which is a little bit quicker than hitting the arrows. And if I can just estimate, like 7 for sure looks to the right of it, so I push 7. That's a little bit quicker than hitting those buttons. And if your whole computer sometimes crashes because you hit too many buttons in a row, that's a nice option. Push enter on the guess, and drag your screen to your notes, or maybe not. Volume was 1512. Now, you will always need units in these questions. So, to the nearest cubic centimeter, what is the maximum volume? So this would be 1512 centimeters cubed. And to the nearest tenth of a centimeter, what size of square should be cut? So 4.5 centimeters to the nearest tenth is the size of the square. And our dimensions now will be 30 minus 9, 21 centimeters, by 25 minus 9, 16 centimeters, by 4.5 centimeters. There are the dimensions of our box. Questions for practice are 3, 4, 5, 6, 9, and 10. We are going to finish up 1.5 this afternoon.